again. So we're on a new standard, 4.OA.4. This standard covers factors, multiples, prime, composite. It tends to be pretty straightforward with the math that you're doing, but there's still work required. You can't just think in and just, I don't know, we're going to pick an answer. There's work with everything that we do. I got company. So you may hear a little background noise. We're just going to roll with it. So I have two vocabulary words up here, factors and multiples. Factors are the numbers that we multiply together in order to get a product. So when we factor a number, we take that product, like let's say 15, and we're going to think about all of the numbers that we can multiply together in order to get to 15. With this one, I told my kids where I had them practice the strategy I call closing the gap. I encourage students to start with 1 and 15 and loop them together. Some students will write out the facts in a multiplication sentence, which if it works for them, that's great. But when we're starting to learn it, I like to do it like this to make sure that we're not missing any factors. Especially if you're working with a number like 24 that has a lot more factors, it's really easy to miss one. So we start with 1, we start with 15. All we do from here is we take it and we move forward both ways. So the next number I think about, 2. Is 2 going to work for 15? Nope, 15 is an odd number. So 15 is not a multiple of 2. So we move on. 3. Is 3 going to work? Yep, 3, 6, 9, 12, 15. So if I skip count by 3 5 times, I get to 15. So this is what I mean by closing the gap. So we know 2 doesn't work, 3 works. So I know 3 goes to 5. So when I do that, I know that 6, 7, 8, 9, 10, 11, 12, 13, and 14 are not options at all for being a factor of 15. We're closing the gap and we're making sure that we're not missing anything. I am done, but I'm still going to think through the process. So the only number between 3 and 5 is 4. Double 4 is the only thing that you can do, and that's 16. That doesn't work, so I know that I'm good. So the factors of 15 are 1 and 15, and 3 and 5. So if I were to write those facts out, I could do 1 multiplied by 15, I could do 15 multiplied by 1, and when we do the factors and we switch their positions, what we call that is the flip-flop, so which is the commutative property. I get a commutative pool where flip-flops. So the numbers can flip-flop around, but the product remains the same. And then we have 3 multiplied by 5. We flip-flop them around, the commutative property. So these are all the combinations of the way that I could write my factors in a multiplication sentence to get to the total, or the product, I should say, 15. So when we factor, we take a product and we split it into those pieces. As I was doing factors, I was thinking about multiples. Multiples simply skip counting. I'm a visual person, I do a lot with my hands if you haven't noticed. And I like to try to create little tips and tricks and things that will make the kids remember multiples. I usually say multiples and I move my hand. And when we think about skip counting, typically it looks like that, especially in a lot of younger textbooks. As I'm closing the garage, we see this movement to indicate skip counting. When we look at the M in multiples, and we drop like that, kind of helps us remember that we're skip counting. So if I'm listing the first 5 multiples of 3, we always start with that number itself. So that would be our first multiple would be 3. Then we count 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I check 1, 2, 3, 4, 5. So 3, 6, 9, 12, and 15 are the first 5 multiples of 3. So multiples, or listing multiples, is a strategy that students can use when they're not quite sure about a multiplication fact. So if they have excuse me, 6 multiplied by 6, they can skip count by 6 times. So we have 6, and 12, 18, then 24, 30, and 6. So just a strategy to help us. So that's basically that. The next ones, oops, I dropped my line in the middle, are going to be prime and composite. Students are so used to, give myself a brain break for a second so I don't spell something wrong, which I am, oops, my husband's a little dead, just not done. I'm notorious for talking and making mistakes when, so, I forgot what I was saying. Oh, when students look at a number like 12, they're very quick to respond, it's even. They hear 17, it's odd. But when we look at numbers and we look at factoring those numbers, when you factor a number, it's going to put it into one of these two categories. The number 15 that we had is a composite number because composite numbers have 2 or more factors. So we have 2 or more factors that can make a product. The other way that sometimes I'll say it, and I like to interchange it so they get comfortable with it, it's more than one factor pair. Okay, so if a number has at least 3 factors or more than one factor pair, it's composite. Prime numbers are straight up that number in itself are the only factors that you can get together to make that product. So only one in itself. Oops. So one in itself. So if we think about the number 3, which is the first odd prime number, the only thing, if we were factoring, that we could think about to get to 3 is 1 and 3. 2 is not going to work, and 3 is an odd number. Okay? So here's a couple of things that I like students to remember, and we talk about when we're dealing with prime numbers. Let's switch colors so we can see. So the first one we talk about is the number 2. 2 is the only even prime because every single even number after that is a multiple of 2. So any even number has to be composite. The only even number that's prime is 2. That being said, a lot of students tend to get in the habit of thinking, ooh, it's an odd number, so it must be prime. However, 9 is not prime. It's actually composite, because when we factor 9, we're going to narrow the gap, so we think about 1 multiplied by 9. 2 is not going to work because 9 is odd. So then we think about 3. So 3, 6, 9. So if I skip count by 3 times and I just kind of horseshoe around it, that's 9. So based on the definition of a composite number, it has 2 or more factors. It has 3 factors, and it has 2 factor pairs, making it composite. But when you list out prime numbers, when you start looking at them, the first prime number is 2, and then we have 3. 4 is not going to work because it's even, so then we have 5, one of my kids. Even number 6, not going to work. 7, yep. 8, it's even, and then we get to that 9. 9 doesn't work because 3 is a factor. 10 is not going to work. 11 is prime. 12 is not going to work. 13. And if you continue that list, they're going to be odd numbers because the only even number that you have is 2. So it's really tricky when you have a list of all prime numbers, all odd numbers, to get kids away from seeing that it is not prime. So let me say that real quick again, because I had a little man come in. So it's hard to get students to not look at odd numbers and automatically think prime. That's why we factor. So factors, multiples, prime, composite all have a hand in each other. Because to determine prime or composite, we need to factor a number. And if you're not sure, we list multiples to help determine if that number is a factor. Okay. The last thing I want to say is about the number 1. 1 is neither prime nor composite because it doesn't fall into any of these categories. 1 and itself, but 1 is 1, so it doesn't have that extra number in order for it to fit in the definition of prime. So that's one of the ones that sometimes we'll see on assessments, and the ones that we give them. We'll throw 1 in there, and a lot of students will go, oh, 1's prime, but it's not. It's not prime, and it's not composite. So the big things to remember, 1 is not prime, not composite. 2 is the only even prime number. 9, not prime, and it's composite. When we factor numbers, we like to start with 1 and itself because, well, unless it's 1, all numbers are going to have 1 in itself as factors. Close the gap, we think numerically in order, we think 2, 3, until we know that we've narrowed the scope on those factors, and if it has 2 or more factors, just like we did for 9 and 15, it falls into the definition of being a composite number. So those are the fundamental pieces that I start teaching with, and then in the next video we'll look at a couple of word problems and look at the application of it and how we cannot let those answer choices get in the way of the answer that we know is right. Thanks.